Thank you, Amanda. All right, everybody should have notes. Everybody should have pencil. Let's get started. Today we are reviewing some probability rules that we are already familiar with from our activity on Monday and the notes that you guys took on Tuesday. Perfect. And then we're going to introduce a new rule that's going to help us calculate probabilities for compound events, meaning an event that represents more than one outcome. Yeah. So let's review our basic rules of probability as a class. Probability of an event is always between which two numbers? 0 and 1. Very good. 0 means the event never happens. 1 means it's guaranteed to happen every time. Most things fall somewhere in between those extremes. It's between 0 and 1 because we represent probability in this class as decimals rounded to 3 or 4 decimal places. Good. Very good. Next one. Probabilities of all outcomes in a sample space should add up to what? 1. Very good, because that's all outcomes, 100% of the possibilities. Perfect. Last one is the complement rule. If I have event A and I have event not A, that should be the whole sample space. So I know if I want to find the probability of not A, that should be 1 minus the probability of A. A plus not A should add up to everything. That's helpful because sometimes it is easier to find A when I'm asked for not A. Sometimes it's easier to find not A when I'm asked for A. So this complement trick is helpful when I'm asked for one thing, but its complement is easier to calculate. So the complement trick will make these calculations faster, which always makes us happy. So let's do an example or two. Start with the first one. It says, although human fingerprints are unique, they can be broadly classified into 3 basic patterns: loops, whorls, and arches. According to Britannica.com, the probability model for these patterns is a loop has a probability of 0.65, whorls have a probability of 0.3, arch has a probability of 0.05, meaning a randomly selected fingerprint has a 65% chance of being a loop. That's what those numbers are telling us. And the first question is, why is this a valid probability model? Why is this a valid probability model? And the answer has to do... Yes, Isabel. Those two things. Did you have a comment? Okay. So first question. Are all of the probabilities in that table between 0 and 1? Check. Yeah. So all probs are between 0 and 1. Happy face. Next check. Do all of those probabilities in our sample space add up to 1? So is 0.65 plus 0.30 plus 0.05 equal to 1? The answer is yes. We have met both of those requirements, therefore this is a valid probability distribution. Those are the two checks. So no negative probabilities, nothing negative down here. If I'm looking at a scenario where I have number output, like rolling a die, it's okay if I have negative values as my outcome. I should never have negative values in my probability. Probability should never be smaller than 0. So don't panic when you see negatives, just make sure they're not in the probability row. Yeah. The other big check, and this is going to be true for the rest of the school year, probability should never be bigger than 1. And I can tell you, at least one of you in this room is going to make that boo-boo when we start running hypothesis tests. You are going to be calculating probabilities. Please do not give me a probability that's bigger than 1. If you see that, it means there's a boo-boo somewhere. It tells you to go back and check. Yeah? Okay. The next question. Find the probability that a randomly selected fingerprint isn't classified as a loop. And the first thing that the AP board is going to want you to do is write that word sentence in probability notation. So P for probability, and then in parentheses, what am I finding the probability of? Not a loop. Very good. Not loop. We just learned a trick for that. Probability of not loop is just 1 minus probability of loop. And probability of loop is something I can look up in that table. What's the probability that I randomly select a fingerprint that's a loop pattern? 0.65, yeah. So 1 minus 0.65, which is 0.35. Assuming I can do math in my head. Out of curiosity, which two patterns are not loops? Whorls and arches. If I were to add the probabilities for whorls and arches, what do I get? 0.35. Yeah. So let's take a look at where that's coming from. We're going to learn a new vocab word. Mutually exclusive. Mutually exclusive. So in statistics, when two events A and B are mutually exclusive, that tells me that they have no outcomes in common. No outcomes in common. For example, if I'm playing with a standard deck of playing cards, I cannot draw a card that is both a king and a queen. It's one or the other. It's never going to be both. So king and queen are mutually exclusive events. A card can be one or a card can be the other. They're never going to be both at the same time. I would like you to take a few seconds in your small groups and see if you can come up with another example of two events in a deck of cards that are mutually exclusive. You should talk to each other. You don't have anyone to talk to. Do you have an example in your head, Brewing? Yeah. No, that's exactly right. Good.
That one is a really good question. I don't know if that's funny to him, but I got weirded out. I was like,
that doesn't sound like statistics.
I have a question.
Yes.
What has to do with the pattern on the card and the number on the card? Because I was saying taking out a 3 of hearts, and then AB 3 and then BB hearts.
So 3 and hearts would not be mutually exclusive because there is a card that is both 3 of hearts. So that's not mutually exclusive. We want two cards that can't ever be in the same category together. Yeah. No overlap. No overlap. All right. Somebody have a good example they want to share with me. Oh, yeah. No, exactly. Tears, frowny face. Brownie. Okay, well, let's go get our name generator. It's too late now. No, pull it up. Name generator. That sounds like a small group problem right there. Brownie. Brownie face. Brownie face. Brownie face. Alex. All right, Alex. An example of two events in a deck of cards that are mutually exclusive. Don't know. Did somebody else at your table come up with something?
Different, like, you know, the other hearts and then the diamond.
The suits. Good. So you can't be a heart and a diamond at the same time. You're either a heart or a diamond. Yeah, very good. Perfect. Why is my little bar not showing up today? Brownie face. Will, can you give me another one?
I would say like the king, queen, jack, and ace. Like each card is usually exclusive to that specific because with the numbers, they still have the same number in different suits. But like, no, that's fine.
Can you just say what Alex said?
Yes, all of the suits are mutually exclusive. So you can't be a diamond and a heart. You can't be a diamond and a spade. You can't be a heart and a club. The face cards and the number cards are mutually exclusive. You either have a face card or a number card. Those are mutually exclusive. Are threes and hearts mutually exclusive? Threes and hearts. We'll say no. Why no? Very good. There is a card in the deck that is both a 3 and a heart. Yeah. So mutually exclusive means there is no card that is both. Those outcomes have nothing in common. When that is true, the probability that you randomly select something that is both should be 0 because it doesn't exist. They have no outcomes in common. If they have no outcomes in common, there's no overlap between these two events, the probability of getting a king or a queen is just the probability of king plus the probability of queen. So when I see or is telling me to add. This is why P not loop, we just added whirl plus arch, because P not loop was P whirl or P arch. And or mean add. And those categories were mutually exclusive. My pattern is one of those three. It shouldn't be in both. I either have a loop or a whirl. I don't have both. Okay, using this idea, take a minute in your small groups. Find the probability that your randomly selected fingerprint is a loop or an arch. Loop or an arch, loop or an arch. Bless you. There we go. Okay. Gabe P. How did you calculate the probability that you got a loop or an arch? So you did P loop plus P arch. So 0.65 and 0.05. 0.7. Can I get a thumbs up if you agree with Gabe? Very good. Loop or arch just means loop plus arch because there's no overlap. They are mutually exclusive. Very good. Okay, another example. Somebody who's got a nice loud voice, would you be willing to read just the lead in to example 3? Thank you, Aaliyah. It's on your paper.
A, the person has high cholesterol, 30 milligrams per deciliter or greater. B, the person has borderline high cholesterol level 2.
Focus, children, focus. I know. I also have allergies and fall and spring suck. I feel your pain. So, you'll notice they gave us the probability for those two events. Yes, probability of A is 0.16. Probability of B is 0.29. And the first thing they ask us is to explain why A and B are mutually exclusive. Why are A and B mutually exclusive? So I'm going to come in here and I'm going to define a variable for us. I'm going to let my cholesterol level equal X. And then I'm going to write a statement in terms of X for each of those events to see if it clarifies a little bit. So A says 240 or greater. 240 or greater. So I know that's an X and a 240. What math symbol goes between those two things? Greater than or equal to. Very good, Caroline. 240 or greater means greater than or equal to. Perfect. B says the person has borderline high cholesterol, 200 to less than 240. So between two numbers, I know I have an X, I have a 200, I have a 240. Symbol between 200 and X. Is it a less than or a less than or equal to? Less than or equal to. They didn't tell us that we were greater than 200. They said 200 is the starting point. Good. Symbol between the X and the 240. I'll give you a hint. It's already on the board. Less than. Yeah. We want to go up to 240 but not include it because once you're at 240, you are then in the high cholesterol group. High cholesterol starts at 240. Do those two number regions on a number line overlap? No. They butt up against each other. Everything up to but not including 240. So 239.999999999. But once I hit 240, I'm in the next group. Good. So no, I know how to write today. Overlap between, and I'm going to use some interval notation here. Bear with me. 200 to 240 and 240, presumably upward. They didn't give us an upper bound. There's no overlap between those two regions. And I can tell because of those brackets. I know round means empty circle, not included. Square means included. If you forget that notation, writing what we wrote up here is also sufficient. But in some way indicate you know those numbers don't overlap. 240 is in one group but not the other. Okay, so the next, why is my board not working today? There we go. Next one says, say in plain language what the event A or B is, and then find the probability that you are in A or B. So they are asking what A or B means. So A or B means A. And we are talking about US adults. So A or B means a random US adult is, and then what does it mean to be in group A? High cholesterol. Good, so it means that random US adult, not is, has high cholesterol. That's group A. Or borderline high cholesterol. Good, that's group B. I didn't want to write high cholesterol again, I'm sorry. Don't judge me. Okay, and they ask us to calculate it, and we just determined that they are mutually exclusive. So Isaac, if I want to find the probability of A or B, what should I do? We're going to wait for Isaac. That's okay. I appreciate the enthusiasm. Or means to do what? I just heard it. Add, yeah, we're going to add. PA plus PB. They gave us those values. PA is 0.16, PB is 0.29. I am fairly certain those are going to add to 0.45. Somebody should check my morning math because my brain is still mush. Thank you, Bree. Or means add, or means add, or means that. We need that in our brain because there really are only two probability rules when it comes to finding compound events like this. Or means add, and means multiply. We're going to see that next one next week. Or means add, and means multiply. Good. Try the next one. C says, let C be the event that the person chosen has normal cholesterol, less than 200 milligrams per deciliter. Find PC. Yeah, very good. PC, which is normal cholesterol, is not A or B. And we know how to deal with not A or B. Complement trick. How do I find not A or B? 1 minus A or B. Yeah. Perfect. And we just found A or B on the last page. A or B was 0.45. So 1 minus 0.45, which is 0.55. So for US adults, there is a 55% chance that a randomly selected US adult will have normal cholesterol, and a 45% chance they will have borderline to high cholesterol. It's a lot of people with high cholesterol. That's something you should start worrying about in your 20s. Because if you catch it trending towards borderline, it's easier to course correct when you're young. It's a lot harder to course correct when you're older. Because the longer you let that high cholesterol sit, the more damage you do to your heart. So my recommendation is at some point in your 20s, when you're in college or you're out of college, have your doctor check your cholesterol levels. Yeah, because that's where they caught mine. High cholesterol runs in my family. They caught it while I was in grad school. Started treating it right away so that I don't die of like a heart attack at 50, like my great uncle did. No, that would make me sad. All right, one more thing today. We'll finish these on Friday. one more thing today, and then we'll finish on Friday. One more thing today. All right, so we've seen two-way tables before. We saw them in Unit 2 when we talked about categorical variable versus categorical variable, right? So it had columns and rows. There were a bunch of numbers in them. It showed the relationship between two categorical variables. In this case, we are going to use them to show the relationship between two statistical events for a random process. They'll look exactly the same. Label, label, frequencies, counts, yeah? But we can use them to model our probability, I guess, display our probability models would be a better way to say that. And even better, they make calculating probabilities for that random process easier. Because all of the counts are in one place. I just have to pick the correct boxes and do the division on a calculator. We like that. That makes us happy. So let's do an example so we can see what it looks like pulling probabilities from a two-way table. Example 4 says students in a college statistics class wanted to find out how common it is for young adults to be able to roll their tongues or raise one eyebrow. They recorded data on whether each of the 200 people in the class could do either of these two things. The two-way table summarizes the data. Suppose we choose a student from the class at random. Define A as student who can roll their tongue and B as student who can raise one eyebrow. Specifically, student who can roll their tongue is a yes. Student who can raise one eyebrow is a yes. So A and B are the yes and the yes. We want to keep that in mind. What does what mean? Okay. So it says find PB. Describe this probability in words. So PB, B is yes, the student can raise one eyebrow. In that table, how many students total can raise one eyebrow? 62. Very good. We want that row total. Out of how many students? 200. Perfect. Number of students who meet that requirement for B on top. Total number of students in the sample space on bottom. Yeah. And I'm pretty sure that works out to 0.31. Check my math. It's been a long morning. Thank you, Will. And they say describe that probability in words. We know we lose points if we don't do that on the FRQs. So what is that telling us? The probability that a random student can, and what is event B? Raise one eyebrow. Meaning if I walk into this class of 200 students, I select one student at random, there is a 31% chance that that kid can raise just one eyebrow. It's an important teacher skill. You have to pass that test in order to teach. Okay, next one. P, roll tongue and raise one eyebrow. I'm going to rewrite that in something slightly less scary, maybe if my pen works. A and B. A is roll your tongue, B is raise one eyebrow. So P, A, and B. And the question is, where in that table are the students who can do both? 42. Yeah. 42 is the intersection of yes, I can roll my tongue and yes, I can raise one eyebrow. Good. How many students? 200. Good. So 0.21. Not so bad. I recognized when I did this yesterday that both of those are even, and if I divide by 2, the bottom becomes 100, and that just moves the decimal place forward twice. Again, I have been doing math for longer than you've been planet Earth, so it's not a fair comparison for what I can do in my head versus what you can do in your head, right? I have been doing math since probably your parents were children. Because I am old. I am old. I know. I have a baby face. It is a curse. So does my dad. And I'm a short king. That doesn't help any. All right. So that's all we're going to cover today. When I see you tomorrow, we're going to pick up with a general addition rule. Does anybody have any questions before we move on to our next activity? No.